Hi guys, welcome back to the Millionaire Mind channel. Today, we will talk about stacks and expression trees. First, what is stacks? Imagine yourself getting food from the cafeteria with your friends. Initially, you would get a tray to place the food that you bought. It is typical for a person to grab the tray that is on top instead of at the bottom for ease and convenience. After eating, you would return the tray. You would place your tray on top of the unwashed trays. Then a friend follows you and places his tray on top of your tray. Another friend follows the two of you and places his tray on top of the current stock of trays. This situation illustrates the concept we call as stacks. Stack is a linear data structure which follows a particular order in which the operators are performed. It is based on the LIFO principle. The element inserted at the last is the first element to come out of the list. That is why you opted to grab the tray that was on top or inserted last. In stacks, the insert operation is called push, while the delete operation is called pop operation, and it all happens on top of a stack. Here are examples. Here, you can see A, B, and C represents the trays. Tray A is pushed since it was the first one that was placed. Tray B is pushed followed by tray C. Now, when a customer comes to get the tray on top, tray C will be popped. The next customer who gets another tray pops tray B. When a new tray arrives and it hasn't been used, tray D will be pushed on top of that tray. That is an example of a real-life scenario involving stacks. In computer science, stacks are used in undo mechanism in text editor like MS Word, language processing, backtracking, or finding our way back in maze problems, and expression evaluation like prefix, infix, or in compilers. Speaking of Infix and Postfix, my friend Rainier knows a lot about them.
Thank you for the introduction, CP. You may wonder, what is an infix and a postfix? Remember when you were introduced to addition as a kid? Let me guess. The first math problem you solved was 1 plus 1. Since we were young, we have grown accustomed to this format, where the operators like plus, minus, times, and divide are placed in between two numbers. In this way, it is easier to read and solve math problems. You might be unaware, but you are actually following what is called the infix notation.
However, it is not the same with computers. For computers, infix evaluation algorithm is time-consuming as well as space-consuming, which can be a big problem while writing big codes.
To overcome this, there is what we call postfix notation. Postfix notation is a notation for writing arithmetic expressions in which the operands, like the numbers and variables, appear before their operators. The main advantage of this notation is that the operands come in the same sequence in which they are to be evaluated. This algorithm saves a lot of time, which is one of the main aims of using data structures. To learn more about converting infix to postfix, here is an example. A times B plus C equals. We will perform this one by one, meaning we will scan each operand and operator from left to right. First up is A, which is an operand. For operands, the general rule is to simply write it down in the equation. What follows is a multiplication symbol, which is an operator. When an operator is read, we must push it in an operator stack. An operator stack is a good way to keep track of the operators in a stack. The top of the stack will always be the most recently saved operator. Whenever we read a new operator, we will need to consider how that operator compares in precedence with the operators, if any, already on the stack. Take note that times and divide has greater precedence than plus and minus. If we are scanning an operator that has a higher precedence than the operator at the top of the stack, then we have to push and pop the scanned operator. On the other hand, if we are scanning an operator that has a lower precedence than the operator at the top of the stack, then we have to pop the operator at the top of the stack and push the scanned operator. If we are scanning an operator that has the same or equal precedence with the operator at the top of the stack, then we have to pop the topmost operator.
Finally, if the symbol you are reading is a parenthesis, push it into the stack. If the closed parenthesis is encountered, pop all symbols between the open and closed parentheses from top to bottom of the operator stack.
Going back to the problem, we are reading the multiplication symbol. Since there is no operator yet in the operator stack, we simply have to push the operator. The next scan is B, and applying the general rule, we will place it in the equation. The operator plus follows. So now, we have to consider our operator stack. Since our topmost operator times has a greater precedence than our scanned operator plus, we have to pop the operator at the top of the stack and push the scanned operator. Popping an operator means we'll have to write it down in the equation. Our next scan is C, so we write it down. After scanning every operand and operator, we simply have to pop the remaining operators in the operator stack from top to bottom. Thus, we pop plus and write it down in our answer. We now have the postfix notation of the given problem. At the same time, we can also express postfix to infix by constructing an expression tree. I bet my friend Andrew has a lot to teach you about the topic.
Indeed, constructing expression trees is an interesting concept. To better understand the process, allow me to take you back to one of your biology classes. Imagine the parts of a tree, specifically the roots and leaves. Roots grow from branching out from the primary root. On the other hand, leaves grow individually from the stems of plant. But secondary leaves do not grow from primary leaves.
The concept is similar to expression trees. The operators are the roots, while the operands are the leaves. Like in biology, roots can branch out while leaves cannot. A binary expression tree is a specific kind of binary tree used to represent expressions. Using the example from a while ago, here is how you can construct an expression tree. AB times C plus equal. Again, we will read the equation one by one, and a good technique is to solve them from right to left. First up is plus, which is an operator. Operators are the roots, so in an expression tree, which is binary in nature, they branch out to two nodes. We write down plus, branching out to two nodes. Next is C. So by general rule, we first fill up the right node. C is an operand, which is like a leaf that does not branch out. So then, we can proceed to the next scan. What follows is a times, and we write it down in the left node. It is an operator, so again, it branches out to two nodes. We can scan B and place it on the right node. Finally, we can scan A and fill up the left node. A and B are operands, so they do not branch out. To check if your answer is correct, we simply have to read the tree from left to right. That's all for today. Thank you for watching. Don't forget to like and subscribe.
Don't forget to ring the bell.
And remember, when you learn many things, you have a millionaire mind.